All right, so today we'll be talking about Alteryx optimization. My name is Stephen White. I'm part of the University Technology Office Data Success Team. I've been with ASU for about 6 years now. And of course, it's always fun getting to speak at data conferences. This is my 5th time. The first one was actually co-hosting with Bob, and we talked about my report's retirement. So it's kind of fun looking back and seeing we finally made it this year. And I noticed there were 2 Alteryx sessions today. So for those of you who are interested in this topic, it'll probably be worth going back and watching the other recording so you get both perspectives. So they're both very similar topics, but we'll cover it from different angles. This presentation is primarily intended for sort of data knight and data wizard levels. Obviously, it's for people who have access to Alteryx. And we're going to be going over some things that you probably know and hopefully a few things that you haven't quite seen yet. So hopefully it'll be helpful for everyone who has at least dipped their toes into the waters of using Alteryx. We're going to be tackling this from primarily 3 angles. I like to think of workflows as starting with an in-database component, typically, depending on what type of data you're connecting to and how your query will be managed. And then the hybrid aspect where you have a mix of in-database and in-memory components, and then the in-memory optimization specifically as well. When I was preparing for this, I searched to see if there was any additional information on optimization, and I found there's an optimization tool. Great. Maybe we can just drag this tool into the workflow and it will optimize everything for us. For anyone who's tried using the optimization tool that's built in, unfortunately, I have to tell you, I don't think this tool does what you think it does. So it's not that easy. All right, so we're going to start by talking about in-database workflows and how to optimize them. When you're building out an in-database workflow, you have different tools involved. There's filters, joins, select tools, and they each help you sort of build onto your query as you manipulate and transform the data that you're querying. I like to think of this in terms of a table. So a table obviously has rows and columns. And the less rows or the less columns you have, the smaller the table is. So when you're designing a query, it makes sense to put tools earlier in the workflow that get rid of as many rows or columns as possible early on to help with the efficiency. So this is just sort of a contrived example. But let's say that we're connecting to the student enroll snapshot table. Now, for those of you that have used these snapshot tables, you know these can get very big. This one happens to have about 1.8 billion rows. And so if you're doing operations that require the database to go through row by row operations, it's going to take much longer than if you can eliminate a large portion of the rows or columns before doing further operations. So in this example, I have 2 different filters I want to use. One is on the student enroll status, and one is on the term. And then I'm also going to be deselecting 80% of the rows and just keeping the 20% that I actually care about. So as a first pass, in this example, I've put the student enroll status filter. But unfortunately, out of those 1.8 billion rows, many of them happen to have this enrollment status. But I'm not actually going to be using most of those rows. And then I have a join where I'm getting additional information from the person view. And then a select tool. And then finally, near the end, I'm filtering down to the specific term that I'm actually interested in. And obviously, in a real life example, you'd have much more complexity. But the point here is that if I were to rearrange this and simply move that term filter to the beginning, right off the bat, I'm eliminating 99% of the rows that were involved in this query. And so if you imagine starting out with a large data set and then immediately filtering that down to just a small subset of what the table originally had, now the database is able to continue working with the query with this much smaller slice of data as it works through the rest of the query. So right off the bat with that first tool, I've eliminated 99% of the data. And then from there, I can apply the rest of my functions or tools. And so this allows the database to work with a smaller set of data much earlier in the query. Now, of course, when you send a SQL that this generates to the database, it's going to interpret that and create an optimization plan, an execution plan. And it may very well, behind the scenes, rearrange this for you without your knowing. So you're going to get the exact same results in the end. But the point here is that by eliminating as many rows or columns as possible, as early as possible in your query design, you're giving the database the best chance of coming up with a good execution plan, and therefore getting your results back as quickly as possible. Obviously, there's some trial and error involved with this, rearranging tools in a different order and seeing whether or not that makes a difference. But as a general rule, if you're able to put your best filters early on, or your best joins early on that get rid of the most amount of rows, that's going to set you up for the most efficient query. As many of you probably already know, using the dynamic output in DB tool, you can get Alteryx to give you the SQL that it generated in the in-database portion of your workflow. Now, these queries are typically very verbose, and they're all spit out as one huge line of SQL. And so if you are going to be taking the SQL out of Alteryx to put into some other tool like Tableau or Report Builder or something like that, it is helpful to at least format the SQL. There's a tool at this DP River website that I found is very useful for formatting SQL. And so that's a good resource to have available. It's much easier to read the SQL when it's formatted. It's a little bit better. Another tip is when you're outputting data to the user database, there are two different types of connections you can use. One is the standard ODBC connection, and the other is called a bulk connection. If you're going to be outputting large amounts of data to a user database table, I strongly recommend using the bulk option. This uses a different set of SQL commands behind the scenes. So essentially, when it's writing data into your user table, instead of writing the data row by row, it will insert them in large chunks, and so it makes it go a lot faster. All right, let's talk about hybrid workflows. These are ones where you have in-database portions as well as in-memory portions. I found working with multiple teams that as your queries begin to get larger and larger, you start to run into issues if you have the entire query as one large in-database workflow. Because Alteryx writes very verbose SQL, it uses a lot of nested subqueries and a lot of aliases. As this workflow gets bigger and bigger, the SQL starts to get really massive. We've seen some queries where it was generating hundreds of thousands of characters in a single SQL statement. And so as you start to run into those issues, the query will slow down because the database is having to translate so much SQL and figure out all of the steps that you were intending it to do for you to get your results set. So one thing that we found to be very useful is to break up the query into logical containers. So this is just a very simple example where we have a little bit of business logic in one container and a separate set of business logic in another container. Each container may be joining a handful of tables, doing some calculated fields, a little bit of aggregation, deduping if necessary, and only returning the columns that we specifically care about. And then at the end of each container, we allow that data to go through to an in-memory portion of the workflow. So some of the benefits of doing this is that you have business logic contained within these different sections. So it's very easy to collapse and expand when you're looking to edit something. So it's a lot easier to maintain. And you also get a lot of performance benefits because each individual in-database portion runs as its own separate query. And of course, each individual query is able to run very quickly because it's only hitting a handful of tables and it's only returning a handful of columns. And so it's very quick for those results to come back into memory. Once each of these containers runs, it's then Alteryx's turn to do the further processing and joining. And thankfully, Alteryx is very efficient with its joins as well. So even if you have hundreds of thousands or potentially even millions of rows coming in from these different containers, the joins tend to be very quick in memory here. And so even if you have, say, 10, 15, 20 in-database containers in this format, you can have all of those containers in your workflow. It will all run relatively quickly, and then allow Alteryx to go through and perform all of the in-memory joins, bringing all of your data together into one large data set. So if you do run into issues where your query seems to be getting too large, but you do still want to have an in-database workflow for maintenance purposes, I would strongly suggest considering this type of approach. And of course, this is a balancing act. So you don't want to have too many tiny containers because you do want to let the database use its indexing and joining power. Obviously, it has a lot of processing power and it's specifically designed to retrieve data. But you want to balance that with not having queries that are so big that you're putting too much strain on the database and sending it massive SQL statements that take it a long time to translate. So just breaking it up into relatively reasonable sizes of SQL tends to work really, really well. So you get the benefits of good SQL execution, as well as Alteryx being able to join up the data in memory. All right, so now we'll get into some of the specific in-memory options that you have available.
Stephen, we have one
yes.
question coming in. It's from Jason Bradshaw before we go to the next. He asking, is it creating CTE for each tool? Is it in that example? So what do you mean by that, Jason? Can you elaborate a little bit on that? Let me unmute you there.
Okay, going back to the dynamic output tool for the when trying to capture the SQL, it looks like it was just creating a bunch of CTEs for each of the in-database tools. I was just curious. That's what it's actually doing behind the scenes. It's probably not important, but I just thought it was kind of interesting.
Yeah, thanks, Jason. So the SQL that Alteryx writes is basically nested subqueries, which is very similar to a CTE. It doesn't use the exact same syntax, but it does nest those queries. What this type of hybrid workflow does is it runs separate SQL statements. So each one of these containers is a completely separate execution with its own SQL. And as the results of each query are completed, those are then passed off to Alteryx so that it can handle them in memory. All right, so there's an option under the workflow configuration within your workbook. There's actually several options in here that we'll go over. One of them is called performance profiling. What this does is it basically adds information to the output of your workflow. So when you finish running it, you can see what percentage of time each of your tools took. So again, this is mostly useful for the in-memory side of your workflows. It's not going to give you any information about any in-database portions of the workflow. But it is helpful if you especially have certain tools that you're using in your workflow that seem to be taking longer than others. This will allow you to sort of identify the cost of each of those tools so that you can see if there's maybe an alternate way of doing a particular function and identify which tools are causing the workflow to slow down. Another option that's available is called the Alteryx multi-threaded processing. It's called the AMP engine. This feature essentially attempts to make the workflow go faster by running multiple threads behind the scenes. So it's taking better advantage of the processing power that your workstation has available. Just to kind of get a feel for how helpful this is, I tested a particular workflow that I have, and it was taking about 10 or 11 seconds to run. As soon as I checked this box, it was taking 7 or 8 seconds. So I definitely saw about a 30% increase in the efficiency of the workflow without making any changes to the workflow itself, just by checking this box. But I did run into one potential issue, which is called a deadlock, which is where the engine had trouble reconciling the different threads that it was running. So essentially, there are certain situations where Alteryx tries processing multiple streams at the same time, but then when it gets to a certain point in the workflow and is trying to reconcile those, it can't figure out how to do it. And so this doesn't work for all workflows. It seems to be relatively deterministic in the sense that depending on your workflow design, it's either going to work or it's not going to work. And so if you happen to get that error, your workflow is just not eligible to use the AMP engine in its current state. But if it is able to run it, speeds it up a bit. Again, this option only applies to the in-memory processing. Any in-database tools that you have are not being processed by Alteryx, they're being processed by the database, and it's just sitting there waiting, so it can't speed that up. And in future versions of the designer, you'll have the option of having the AMP engine enabled by default, so you won't even have to think about it. It'll just run for any workflows that you build. Next, we'll talk about caching. There are several different ways that you can cache data in your workflow. And of course, caching is simply the ability for Alteryx to memorize certain portions of data so that when you rerun the workflow, it doesn't have to go fetch all of that data again from scratch if it doesn't need to. If it's able to use cache data, it will just reuse it for you. In the input tool, there's an option, number 4, that specifically is called cache data. So it's very straightforward. This is primarily if you were connecting to, say, an Excel workbook, for example, and you were querying a large Excel workbook. Rather than querying the entire workbook again every time you run, if that file hasn't changed, it can just pick up from where it left off with the memory that it already, with the data that it already had in memory. And so that can speed up your workflow. I find that these are primarily useful during development when you're working on making changes to a workflow, rerunning it to see how your changes went. It just speeds up that process of rerunning the workflow over and over as you develop it. Similarly, with the in-database browsing tools, you have the option of enabling caching on those. This is particularly helpful when you have many browse tools throughout your query that you're using to test to see what the data looks like as you go along through your query. By caching just a handful of records, it will allow that query to still run more efficiently, but you'll be able to see what the data look like along the way to help you understand whether or not your query is working as you intended it to. And with any in-memory tool, you have the option of right-clicking on it and asking it to run the workflow up to that point and cache the data. So depending on what your workflow looks like, if you have tested it up to a certain point and you're developing the next section of your workflow, sometimes it's helpful to cache the workflow up to that point. So whatever kind of in-database or in-memory transformations were going on before then, you're able to just temporarily set those aside and focus on one particular part of your workflow and rerun the workflow much more quickly as you develop it. All right, and I just have a handful of sort of final tips to leave you with. So not a ton of information, but hopefully some of this is helpful. In the in-memory join tools, especially if you have a lot of join tools that you're going to be using, I find it very helpful to deselect any columns that you're not going to be using down the line. This is especially the case when you have columns with the same name in multiple tables. So for example, if you're joining on your EMPL-IDs or your S-term or whatever, instead of ending up with multiple columns that have the exact same information in them, it's helpful to deselect those early in the workflow. And so you're dealing with just the columns that you actually need as you go forward. Another option that I've found that can be very useful back in the workflow configuration again is the option to either disable all your browsing tools or to disable tools that write output. So again, this is mostly helpful during development. If you're not ready to overwrite your output, especially if you're writing to a table, you can temporarily disable that and continue running and testing your workflow while you make changes. And similarly, if you're not interested in browse tools, but you have a bunch of browse tools throughout the workflow, you can temporarily disable those and skip over them while you test the other portions of the workflow. So just kind of to recap, as you're building your workflow, it's very helpful to think about the amount of data that you're working with in terms of the number of rows and the number of columns that are involved, especially during testing. It's helpful to limit the amount of rows as much as possible that you're testing with, and remove unnecessary fields as early as possible in the workflow. I find especially that during testing, putting a temporary filter early in the query helps a lot with just testing whether or not the query is working for a handful of records. And then, of course, removing that filter once I'm ready to do my final QA. If you have a lot of browse tools all throughout the workflow, getting rid of those or temporarily disabling those tends to have a pretty significant performance impact. And then if you've organized your workflow into containers, you have the option of disabling each container that you don't want to use at the moment. So disabling your unused containers allows you to just focus on the portion of the workflow that you're working on at that time. So that can also be very helpful. In certain tools, such as the select tool and the join tool, if you've moved it around a bit and made changes to your workflow, sometimes you'll notice that there are missing fields listed in there, and those can really clutter up the list of fields. And so in the options menu, you can click on forget all missing fields, and it will simply clear those out for you and leave you with just the fields that are currently applicable in your workflow up to that point. Another thing that I found is helpful is if you have a union tool, which are especially used to left join data in memory. You have the option of ignoring warnings. And so that actually helps with issues where it may be giving a whole lot of warnings, and in your results, it will clutter up the results of your workflow when you're trying to see how it went. And so by ignoring those, it can actually speed up the workflow as well. All right, so that's all I had for you today. Pretty quick summary of tips that I found to be useful, especially during development. So hopefully some of that will benefit you as you continue building workflows. Any questions for me about things we've covered today? Denise said she likes the ability to disable output. Yeah, it's nice to not accidentally overwrite a table when you're testing things. Okay, great. So hopefully between this session and the other Alteryx session, if you're able to watch that later, you'll have lots of useful tips to help you with your development. And as always, our team is available for consultations as needed. So let us know if you need any help if you get stuck.